Hello everyone, let's begin our tutorial of PLC control system in Automation Studio. Next, I will present two examples, a lock and a traffic light, which are both controlled by the PLC and then presented in a simulated way. And firstly, it is the example of a password lock. The whole control system is made up of Siemens PLC components, mainly including counters and comparators. The heart of this example is how to apply a counter to the PLC. And we can find a counter in a library, letter, in letter for Siemens PLC. Click on the timers, the counters. There are three different types of counters in it. And if we select the counter and click on the help icon at the top right corner for more information. In the help screen, we can see how these ports changes. What we use most is the CV port, R port, the CU port, R port, and CV, and also Q port. From the information, if the state of the R input signal changes from 0 to 1, the counter is initialized at 0. So the R port is the reset port. And if the state of the CU input signal changes from 0 to 1, the value of the CV counter is incremented by 1. CV, which means current value of the counter. The most common concern in our simulations is the value of the CV, because it is about whether the program is running in a right order. And then here is the comparator. If the CV is the CV in the counter is equal to the value preset in counter in the comparator, its output ports will be powered up, and we can change the preset value in the components properties screen and the data, and we can change it in here. And there is the memory coil. Set or reset the signal it has received. Let's simulate the circuit at first to see how it works. The unlocking condition of this password lock is set as pressing B2 and B3 respectively 3 times and 2 times. At the same time, B2 and B3 should be pressed in order. Press B2 first and then press B3. And B3, and if I press the B2 for 3 times, the counter C0 and C1 will count up, and the CV will show the status of the counter, like 3 times, and then 2 times of B3. And next, we will move on to the comparator area. If the numbers set in these two comparators are equal to the CV, and then press the unlock button, the out0 coil will get powered and the green indicator will light up, which means the password lock will be opened automatically. And the yellow button is the reset button. When we press it, the reset coil will get powered, and we can unlock the password lock again, and all counters will be reset. Okay, let's see the wrong condition. And there is a parallel circuit which is equals to all logic in gate level primitives. So if we press B4, B4 or B2, B3 are pressed in wrong sequence, any of these conditions is fulfilled, the red indicator will light up, which means the alarm is activated. Okay, that is the password lock control system. And secondly, we'll choose on the traffic light PLC program. Yeah, it is the example for realizing automatic control of the traffic lights at intersections. The entire program is driven by a timer, and the green light in the north south direction. The green light in the south direction will light up for 6 seconds, and the flashes for 2 seconds. The yellow light for 2 seconds, and the red light 10 seconds. The traffic lights in the horizontal direction also change in accordance with this law. B2 is the stop button. In order to achieve this change, timers and comparators are used to make sure which light should be on in different time period. For example, when the value of the timer is greater than 14 and less than or equal to 20, the coil M7 will get powered, and M7 is also linked with out 6 coil, which is the red light in west east direction. And also at this time, the corresponding green light on the other side should also be on. So that is auto 1, the green light, and we can see M7 is also connected with auto 1. So let's simulate the circuit to see how it works. We can see the green light and red light light up simultaneously and flashes for 2 seconds. 2 seconds for the yellow light, and then the red light. So 2 seconds. So that is a cycle that is one cycle. And in order to achieve the blink of the green light, the control system requires a pulse generator. However, unlike other professional PLC program software, there is no PLC signal module in Automation Studio which can generate pulse automatically. Therefore, it is necessary to design the clock pulse generator in the ladder diagram, and here is the pulse generator. The principle of this part is T79 and T78, and T39 and T38 will both count for 200 milliseconds one after another. The activation of either timer will result in the deactivation of the another. It's just like giving a pause to the coil. Okay, that is the traffic light control system. Thank you, everyone.